do not worry about what you are going to achieve in 6 months or 1 year. Worry about what you are going to do today and tomorrow. That's it. Whenever you are studying a particular topic, do not jump into mathematics without understanding the fundamental law itself. Whenever you are studying, even you are deriving mathematics, you need to understand the fundamental principles which are guiding those mathematical derivations. But remember, the syllabus is really huge. You also have to study GS. So you have to make a very good balance here. So stick to syllabus and do not try to jump into topics which is not part of the syllabus.
Hello and welcome everyone. As part of our optional strategy series, we have lined up a session on physics optional strategy for 2025. Joining us today is our esteemed faculty member Abhishek sir, who has been guiding students in subjects like environment and science and technology for a very long time. Apart from the GS subjects, he has a passion for physics and a very clear understanding of what is required in physics optional for the UPSC examination. Welcome Abhishek sir.
Thanks a lot for having me.
Sir, let's dive right in. Why should a student choose physics as an optional? What are the advantages that he or she may get?
Physics can be a strategic choice when you are exploring optionals. There are many reasons behind it. The first is that it is a science subject, and because of that you do not have any subjective interpretations in an answer. So if there is a question, you know what the answer is, you know these stages, you know the derivations, and you also know what will be your final answer. So everything is fixed and there is no scope of subjective interpretation here. That is a very important benefit, because once you complete your syllabus, once you do the subject well, then you do not have to worry about subjectivity in your answer writing. The second part is that syllabus is very static. There is no current affairs per se. And because of that, you can expect questions on similar line what have been asked in last 5 or 10 years. The third very good reason is that almost identical syllabus is also in Indian Forest Services examination. So candidate who is appearing for civil services examination can choose physics as one optional and perhaps forestry as another optional, and can also appear for Indian Forest Services. So that is also an advantage. And because of all of this, if you look at the track record, even though few students choose this as an optional subject, but those who do, and if you look at the final list also, you'll realize that students are scoring easily around 300, so 280, 300, 330. In fact, students have scored 340, 350 also. So along with maths, physics becomes one of the highest scoring optional subject in UPSC examination.
Sir, the scores that you already mentioned that the students get, it's very tempting for the students. So I just want to clarify, in your opinion, who are the students who should take physics as an optional?
That's a very good question. So I do think that students who have background in engineering, physics, or even mathematics, and they have passion for the subject, they can dive right in and they can choose physics as an optional. So yes, you need to have a background in physics, a background in engineering, or a background in mathematics, and also you need to have interest in this subject and passion for this subject, and that will help you a lot in your preparation.
Okay. Sir, now that we have a brief idea of why the syllabus, the particular subject is very important and how it is beneficial to students, I request you to explain in brief what is the structure and nature of the paper, physics optional paper in general.
To answer that question, we need to describe the syllabus. Every optional has 2 papers. So in physics paper 1, the topics you study, you get to study about developments which happened in 19th century and before that. I'm not saying that everything is only from 19th century and before that. There are topics like modern optics or Fermi-Dirac statistics which were developed in 20th century. But in paper 1, you mostly get to read about some of the great giants of physics who laid the foundation of the subject, such as Sir Isaac Newton or Boltzmann or Maxwell, or even some basic ideas of Einstein, because you have to study special theory of relativity. And if you go to paper 2, then paper 2 starts with quantum mechanics, and quantum mechanics was a result of development in 20th century, particularly in first half of the 20th century. And of course, subject kept on evolving. So it starts with quantum mechanics, and that is why you get to study about scientists like Heisenberg, or you get to study about Schrödinger, and you get to study about Dr. C.V. Raman, in fact, in spectroscopy. So the giants of 20th century you get to study in paper 2. So paper 1 includes classical mechanics and relativity and waves and optics in section A. And then in section B, it includes electricity and magnetism and thermal and statistical physics. These main subjects are further divided into many subtopics, and we will talk about that also. But paper 2 also has two sections. Section A comprises of quantum mechanics and atomic and molecular physics. And section B comprises of nuclear and particle physics and solid state physics, devices and electronics. So even by looking at the names, you can see that how quantum mechanics is the foundation in paper 2, while classical mechanics and early developments in electrodynamics and thermodynamics, they are foundations in paper 1. So do you want me to describe the sub-syllabus further?
Sir, I would like to know to what extent the student will have to dive into a particular subject. For example, classical mechanics in itself is a very wide subject.
So again, I have to answer this for each and every topic and subtopic respectively. Okay, so let's start with classical mechanics and relativity. If you go and look at the UPSC syllabus, it is further divided into many subtopics. It starts with some of the fundamental ideas of classical mechanics. Then it also talks about rigid body dynamics. It talks about mechanics of continuous media. For example, it talks about the concept of stress and strain, or Bernoulli's theorem in fluids. Then it also talks about special relativity as propounded by Einstein. And within syllabus, keywords are mentioned. So you need to definitely know about those keywords, what they are. And then you need to understand the mathematics behind those keywords. There are standard derivations which you have to do. You have to learn them. But it's not about, one very important thing I must highlight here is that physics cannot work upon rote memorization. So let me further dive into the topic of classical mechanics, if that is fine. The very first one of the fundamental concepts you study in classical mechanics is about conservative forces. And you study that if there is a force field given, you take del, you take a curl of that force field, and if it is 0, then it is a conservative force. So if you know how to do the mathematics, a force field is given, you are taking del of that curl of that force field, and you know that it is 0, and you have your answer. But if you cannot appreciate that why that del cross F is 0 is a necessary and sufficient condition for a force to be conservative, then you are not on the right track in your preparation. So for each and every topic, whenever you are studying, even you are deriving mathematics, you need to understand the fundamental principles which are guiding those mathematical derivations. So physics builds upon itself. You need to remember that how science as a subject develops. Science does not accept any type of authority per se. It evolves itself based on new and new findings. So, and that is how physics has also built itself, that so many different subjects people studied separately. Optics was studied separately, electricity and magnetism was studied separately, and now we know that the subject of electrodynamics combines both of them, that you cannot be very good at optics if you do not understand about electromagnetic theory, and you do not understand electromagnetic theory if you do not have very good idea of electricity and magnetism. So things are interconnected and interrelated, and appreciating those interconnections with the help of fundamental principles, natural principles, is very, very important. In classical mechanics, there is a good thing. There is also, I also would say that perhaps it is also an unfortunate thing, that one of the most amazing area of classical mechanics is study about Lagrangian and Hamiltonian mechanics, which is not part of your civil services classical mechanics syllabus, which makes this syllabus little bit lighter, but also you get to miss on some of the really interesting ideas of classical mechanics. In relativity, you do not have to study general theory of relativity, you only have to study special theory of relativity. But here also, for example, you have to look at the historical development here. And UPSC has asked questions, for example, the failure of Michelson-Morley experiment. And UPSC has asked questions about that what was that experiment all about and how it paved the way for special theory of relativity to emerge. So you need to know that also. And of course, then you need to do Lorentz transformation. There are some standard derivations. And of course, you have to then learn how to derive length contraction and time dilation. So your question was that up to what depth? So there will be two types of questions. All the keywords which are given in this syllabus, there is a underlying physical principle, and based on that there is often a mathematical derivation. Mathematics is the language of the universe. Without mathematics you cannot do physics, right? So you understand the basic laws of physics, and then based on that you do mathematics. That is a standard question, a standard derivation. For example, there is a part of the syllabus, Rutherford scattering, a very famous experiment conducted by Rutherford. And then there is a proper setup there, there is a proper mathematical derivation there. So UPSC can simply ask questions that what is the cross section in Rutherford scattering. So that will be one type of question. The second type of question will be some numericals, that there is an expectation that you know the formula here and you know how to apply that formula. But often those questions will be not directly that you put some data and your answer is there. There are questions like that. There are some easy questions like that. But often questions will also be that you'll have to apply your mind and you have to think about a question for a moment and then you are answering a numerical. So questions are frankly not difficult. And those who have background in physics, they will appreciate that questions are not very difficult. For example, think of when you prepare for IIT-JEE examination, that you have studied all the concepts and based on that there are numericals, and those numericals are not that straightforward and you have to think then and there a lot and then you get the correct answer. In UPSC examination, the syllabus is huge, but the questions are not that difficult. Questions are very standard. Questions are often repeated after every 2-3 years. So if you have a very good grasp of previous year questions, you can do your syllabus really well. Let's go to the next part of section A, which is waves and optics. So in waves and optics also it is further divided. You have to first know the basic ideas of wave theory. In optics you have to know about geometrical optics. In geometrical optics, for example, the topic of aberration is very popular in UPSC examination. Then you have to study about interference, you have to study about diffraction, and the most favorite topic of UPSC is modern optics. Most of the questions from optics, or many questions of the optics, are asked from modern optics. In modern optics you get to study about polarization, about lasers, all of those things. In section B, the first part of section B, electricity and magnetism, I would say that this is perhaps one of the difficult part of the syllabus. Optics is one of the easiest part of the syllabus of section A, but section B, the first part, electricity and magnetism, which is also the important part of section B, is difficult. Difficult in the sense that if you again do not grasp the fundamental principles, then the subject becomes difficult. If you do not appreciate electrostatics theory, if you do not appreciate the concept of field, then it will turn out that you will not be able to appreciate remaining topics at all. So a very fundamental foundation in electrostatics will help you a lot in other part of the syllabus. So you have to also study magnetostatics. You also have to study current electricity, both AC and DC currents in detail. The fundamental laws such as Ampere's law, or Lenz's law, or Biot-Savart's law, all of those laws you have to study in great detail. And a difficult part of the syllabus is electromagnetic theory and black body radiation. It is difficult because the mathematical derivations are much more complex, perhaps some of the most complex derivations in paper 1 syllabus. But at the same time, the other part of the section B, which is thermal and statistical physics, so you get to study thermodynamics and statistical physics. This is one of my favorite areas of physics, to be honest with you, because when you study thermodynamics and statistical physics, you realize the power of whatever you have studied till now. That how you can connect the micro to macro. At macro level, you study things like pressure and temperature. At micro level, you get to know about distribution of particles into different energy states. So while thermodynamics handles macro, statistical physics handles micro. But then they two become intertwined and interconnected with each other. And when you appreciate that, then the magic occurs, right? So thermodynamics particularly, I would say that conceptually it is very interesting and the questions are not that difficult. So this will be again one of the easier part of the paper 1 syllabus. If I come to paper 2, the section A has quantum mechanics, and quantum mechanics has the highest weightage in section A. Quantum mechanics prima facie is counterintuitive. You deal in abstract space, you deal with vector space, abstract mathematics, and then you suddenly realize that this abstract mathematics is telling us something concrete, and that something concrete can be verified experimentally, right? So you first again need to appreciate quantum mechanics, because you are delving into a counterintuitive realm where your logic and your senses will not come to your rescue. You have to rely upon your mathematical aptitude to appreciate the topic, right? So you understand the limitations of human sensory capacity, but then, and that is, by the way, it is because of one of the favorite quote I will say is a professor from IIT Madras, Dr. Balakrishnan, and one of the quantum mechanics courses, he makes a very popular statement that this entire problem with quantum mechanics, that why people cannot appreciate is problem of our language, that English or any other language for that matter simply is not equipped to deal quantum mechanics, to deal with wave particle duality, and that is why you have to rely upon mathematics here. Mathematics is the most elegant language and it does help you a lot in quantum mechanics. So quantum mechanics, prima facie the derivations looks very complex, but I can assure you that mathematically classical mechanics is more difficult than quantum mechanics. So the differential equations may seem very lengthy, but turns out you do not have to actually derive those differential equations. There are ready-made solutions and you have to simply write that this is the solution to equation. So if you write equations, it looks very complex, very lengthy. The solution often go into 2 pages or 3 pages. However, when you actually understand quantum mechanics, and then you realize that mathematically it is an easier subject, and it is the most important subject, also the most scoring subject in paper 2. Compared to that, within section A, you have the next part, which is atomic and molecular physics, and in atomic and molecular physics, you first get to study about detailed structure of atoms, starting from Bohr's model, but also to more advanced models. But the main part of this syllabus is in atomic physics, things like LS coupling and JJ coupling, which again, mathematically they are very simple, but conceptually you need to appreciate. If you, without understanding the physics of LS coupling and JJ coupling, if you simply jump into mathematics, it's not going to be of great help, because even if UPSC twist question a little bit, and you'll not be able to answer those questions because you focused a lot upon simple derivations with rote memorization. That is not going to help you. Molecular physics is about spectroscopy, that you study about spectroscopy in great detail, that why molecules absorb or emit certain frequencies of light and certain frequencies they do not. You also get to study about Dr. C.V. Raman and why Raman spectroscopy is one of the most important domains in the field of technology. So this part, atomic and molecular physics, is relatively easier in section A. But immediately after that, when you start section B, I have talked to many candidates, and then section B, generally in paper 2, aspirants do not spend a lot of time and they feel difficulty, and the difficulty is because of the vastness of the syllabus. The first part here is nuclear and particle physics, and nuclear physics and particle physics, they both are, particle physics is not that lengthy, but the syllabus of nuclear physics is very lengthy, and that takes a lot of time, yes. But if you have a very good foundation in quantum mechanics, then the mathematics part of nuclear physics is much more easier. Conceptually, you have to, we cannot imagine things which are happening at the range of femtometer, but conceptually it is, if you have a good grasp of quantum mechanics, it's not a difficult subject. Particle physics is really an amazing part of your syllabus because it is also not very difficult. That is the first thing. And the second thing is that this is one area where you realize that so much of work is happening even right now, that you'll be able to appreciate all of those particle colliders such as Large Hadron Collider or Fermi Lab in America, and or Indian Neutrino Observatory for that matter, which is under construction in Tamil Nadu. So you get to appreciate all of those things. So when you study particle physics, you realize that this is one area where research is happening as we speak, right? Then the other part of the syllabus is solid state physics, devices and electronics. This is also one part of the syllabus which often aspirants in fact skip, and the reason they skip is that out of 8 questions you only have to answer 5 questions. So they try to answer the question of quantum mechanics and atomic and molecular physics, and they do not take care of this. But then this will reduce your marks, because remember, even in section B, apart from that compulsory question number 5, you still have to attempt one question from either question 6, question 7 or question 8. And any of those questions from solid state physics, electronic devices, you'll not be able to answer, right? So solid state physics is again a difficult subject compared to the earlier part of the syllabus, but the foundation in quantum mechanics will help you here also. So paper 2 is founded on the ideas of quantum mechanics, and you appreciate solid state physics once you have a very good grasp of quantum mechanics. The other part of the syllabus is electronics. So you get to know about semiconductors in much more detail. You get to learn about circuits in much more detail, and many of the electronic devices which we use in our day-to-day life. For example, you learn about transistors or amplifiers, or you also learn about solving digital circuits. So those things have real life applications in our day-to-day life, in fact. So I highly recommend to aspirants that it will take some time, but once you do this part, then this is not that difficult. For example, for me, I would say that nuclear physics perhaps is little bit on difficult side compared to semiconductors and electronics part. So this part also should not be skipped, and if you do this part also, then you can score really well in paper 2 also. So this is a comprehensive description of the syllabus and the level of difficulty. I assumed one thing, I assumed that aspirants know about the question structure. So if you did not, I will just briefly explain that what is the structure of the paper. In paper 1, again there are 2 sections. Section A will have 4 questions and section B will have 4 questions. So there are total 8 questions. You have to attempt only 5 of them. But section A, you have to attempt question 1, that is mandatory. Question 1 will have 5 more questions. Every question will have 10 marks. And section B also has question number 5, and that is also mandatory. And out of remaining 6 questions, you have to attempt 3, right? However, you must attempt, apart from question 6 in section B, you have to attempt at least 1 question from section B. Similarly, if you are attempting 2 questions plus mandatory in section B, you have to attempt question 1 and any of other 3 questions in section A. So this is the nature, and the same thing is also replicated in paper 2.
Okay. Sir, in the overall sense, what I gather is that you should have a very clear understanding of the syllabus. Yeah. Every keyword of the syllabus, you should have a plan for it, a strategy for every keyword of the syllabus. Yeah. And from the skill side, you should have a clear understanding of physical principles that are being applied here, an idea of the formulas and their applications, and the associated mathematical aptitude. Okay. Now that we have a decent enough understanding of the syllabus and the nature of the paper, sir, you mentioned that there are some foundational values, and many of the time students also complain that their foundational values are weak or their foundation skills are weak. Okay. So what do you recommend? How should students strengthen their foundations with regard to skills and principles before going on to the preparation for the physics paper?
Okay, so I am assuming that you have a background in engineering and mathematics or physics if you have chosen physics as an optional. So first I would highly recommend that go and read your class 11th and 12th when you studied physics at that point of time. And by the way, you'll be surprised to know that a good percentage of syllabus can be covered only with your foundational knowledge from class 11th and 12th. And many questions you can solve, by the way, in UPSC examination also, if you have just studied class 11th and 12th physics. But of course, that is not going to be enough. So to build your foundation, you have to refer to basic textbooks. And the good thing here is, again, because the syllabus is static, the reference material is very easily available in the market. And whenever you are studying, as I was talking about earlier, whenever you are studying a particular topic, do not jump into mathematics without understanding the fundamental law itself, right? You study about divergence, that this is how we calculate divergence, but you do not even appreciate what divergence is, then that is not a very good study, that you have to understand what divergence is, right? So once your foundation is strong, one of the best example I will tell you is that a very amazing book written by Griffiths for electrodynamics, which is also a standard textbook all aspirants refer to. Griffiths is it's like a Bible for the electrodynamics topic. And when you study the first 2-3 chapters of Griffiths, and then he says that we are done with electrostatics. And after that, he goes on to write on electrostatics at least 2 chapters, only delving into mathematics. But to write those 2 chapters, he first has 3 chapters which in detail talk about the theories, they talk about constraints, the problems, the challenges, what challenges physicists faced, how they try to overcome those challenges. So once you appreciate those things, the topic becomes very simpler, because then you will not find any problem in appreciating the mathematics part of it, right? So what I will highly recommend is that understand each and every keyword of the syllabus really well, familiarize with self with each and every keyword, understand the basic fundamental principle of a particular keyword. When you are making your notes, then have proper headings and subheadings, right? Those headings and subheadings should not be on very heavy on content. It should focus on summarizing the key concepts. Your notes also should have good illustrations. For example, whenever you have diagram, whenever you have graph, any type of chart, you definitely try to incorporate them, because that will help you a lot in revising things, and particularly that will help you a lot in answer writing, because UPSC does expect you to write answer with proper illustrations, right? So that is going to help you a lot. Mentors are there, teachers are there, take their support. If you have any difficulty in grasping a concept, do not hesitate in asking questions. I often tell this to students, that science progresses by asking questions which may seem very silly, but those questions inherently are very profound. For example, before Newton, people did not think that why that apple is falling on the ground, and perhaps the question seemed like a silly question, because this is something which you take for granted, that apple falls on the ground. But Newton thought that why is it so, and he discovered gravity. So that is how, and when you chose physics as an optional, this was a conscious decision that you have a passion for the subject and you want to replicate it. So in the process of preparation, do not lose that passion. Remember that why you took this subject, why you chose this subject as an optional. And if anybody is telling you otherwise, then don't follow that advice, that no, you'll have to memorize these things, there is no other way, iska aur koi tarika nahi hai. Not at all, aisa bilkul bhi nahi hai, nothing like that. So do not forget that why you took this subject. Keep having that same passion for this subject. Do not directly jump into rote memorization, mathematical derivations without appreciating the physics part itself, right? And then one thing should be very clear, that syllabus is very limited. You, in your UPSC preparation journey, limit yourself to the syllabus. There will be many other things which you could study. For example, you started studying about special theory of relativity and you felt that I should also want to know about general theory of relativity. You delay that. So once you clear the examination, become a civil servant, and then you go and explore general theory of relativity. So this is where I would say that I am not saying that don't be curious, definitely be curious, but remember the syllabus is really huge. You also have to study GS, so you have to make a very good balance here. So stick to syllabus and do not try to jump into topics which is not part of the syllabus, because that will be not very good in overall your strategy.
Okay, so sir, as far as I understand that, firstly stick to your foundation, the +1 +2 syllabus that you studied, or whatever you studied in your engineering, or if you took physics or any other technical optional. And apart from that, one has to limit oneself to make sure that he does not digress.
Yeah, okay. That is important.
Any other pointer you would like to highlight to make sure that the general strategy for preparing for UPSC exam is sound? You also mentioned in your earlier discussion about the PYQs. How should one use the previous year questions in their preparation?
Okay, that's a very good question actually. Almost all optionals have some questions which do get repeated, but in physics, because there is no current affairs per se, the syllabus is very static. So if you have a repository of 10-year question, and how I will try to use PYQ, that let's say you have a particular keyword in the syllabus. In electricity and magnetism, you have Laplace equation. Then you are looking at the questions from Laplace equation in what UPSC has asked in last 10-15 years. And then you realize that the next year the question will be on similar line, if not exactly identical, right? So do PYQs of last 10-15 years topic wise rather than year wise. Do it topic wise. So pick a specific topic from a specific section. So within quantum mechanics, you have to study Heisenberg principle of uncertainty. You have to study the concept of expectation value. You have to study the concept of wave particle duality. You have to study the concept of rectangular barrier, step potential. So you pick questions from these specific topics in last 10-15 years. And you have now a very good repository of those questions. You solve those questions and you immediately realize, when you go and appear in examination, you realize that this was perhaps the most important resource available, because this question is either identical to what I already have done, or it is very similar to what I have already done, right? And that is how you gain confidence and you realize that you can score really well in this particular paper. So PYQs are very, very important. Practicing is very, very important. Do not be complacent even for a bit. Always remember that this optional is one of the, it can be a strategic choice, but it does require a lot of hard work. In fact, it can be, that statement can be made for each and every optional. So in physics, you have to work really hard. You have to practice a lot. Whatever you have already studied, try to revise this after some gap of time. Otherwise, we tend to forget things. So remember that we have to practice. Practice makes us perfect. It's a cliched statement, but it is cliched because it is also true. So practice, practice, practice. And PYQs are perhaps the best sources to do it there, right? So choose previous year questions from section, subsection, and answer all questions in last 10-15 years. And then you can also answer the next year question in men's examination.
Okay. Sir, you mentioned that one has to extensively practice, and you also mentioned that one should revise regularly.
Yeah.
This is a very critical pointer for students who, especially for the students with the technical optional, that how should one revise, what should be the strategy, how should one make notes, and how frequently should one revise the overall things that they have studied?
Okay. That's again a very relevant question. So I will divide this into two parts. The first part is that the first part will focus upon summarizing things. We can choose any topic. For example, let's choose atomic and molecular physics. You look at this syllabus of atomic and molecular physics. You have understood the theory really well. You know what type of questions UPSC does ask, because you have looked at the previous year questions. Now the next and last step here will be that you try to concise everything on a piece of paper as precisely as possible. So Zeeman effect is part of the syllabus. You know what is Zeeman effect, you know the basic derivation also, but there are many numerical questions from the final formula of Zeeman effect itself, and you have kept it, you have written it down at one place. So and do that for each and every topic. In classical mechanics, there are certain derivations, certain formulas which you have noted it down. In your mind, you know the physics, you know the steps, you just have the final thing as a ready-made summary which can be revised from time to time. So that is the first part, that you must summarize. The second part, how to revise things. There is a scientific way to revise things, and this is, by the way, not just applicable for physics as an optional. You can use that in general studies also, that you try to increase the gap. So for example, as you gain more and more knowledge, it's clearly not possible that whatever you are studying each and every day you are also revising whatever you have studied in the past. That's not going to happen. So there is a very scientific way to do that. So whatever you have studied today, a new topic you have studied today, you revise it next day, you revise it then 3 days later, then 7 days later, then 20 days later, then 2 months later. So you will realize that I am following a pattern, that I am increasing the time gap, and this is a scientific method to remember a concept for very, very long duration, right? So, and if you, by the way, there are certain claims, and those claims, however, have to be validated. There are certain claims that if you follow this for, let's say, 2 years, then you get to remember a particular concept for your entire life. So some people have made these claims also. But this is a very good way, that without feeling overwhelmed from the weight of the syllabus, you keep increasing the time gap in whatever you have studied. So today, 3 days later, 10 days later, 20 days, you get the idea, but keep doing that. And that you'll realize that now you remember each and everything. So this is how we revise things. And I do think that this will also help you in general studies, not just in physics as an optional, or for that matter, any optional.
Sir, many of the students have a question that should they use test series as a tool for revision? What is your take on it?
Definitely, because how are you going to assess yourself? In your mind, you have studied things well. You have understood everything. Again, I am assuming that whatever I just said earlier, you understood physics, you understood the basic derivations, you have summarized things also, and you have to go and you have to go and write UPSC mains examination. But before that, you have to check yourself. So test series does play a very important role, that you get to assess yourself, and you get a support from a mentor, a teacher, and if there are any shortcomings, then you get feedback from that. Your answer may be correct, everything you have done is correct, but maybe there is a scope of improvement, maybe there is a diagram which you could have drawn but you did not. Maybe there was a physical principle which you should have written in the answer but you did not. So those small feedbacks will increase your marks even very marginally in each and every question. Then a cumulative effect will be much more. So that is why a good candidate will score 280 also, and a good candidate will score 340 or 350 also, right? So even among good candidates in physics and optional, there is a variation. There are students who are scoring 340, but there are good candidates who are scoring 280. So, and that difference is those minor changes which you make in your answer, that you apply physical principles, whatever you have done, you are noting it down, you are highlighting those things. There are certain diagrams which you ideally should have drawn there, but you did not. So those things will help you a lot. Okay. So test series definitely is going to help you a lot in this particular aspect.
So, sir, in essence, one should create a precise formula sheet.
Yeah.
Apart from the formula sheet, one should regularly practice.
Yeah.
And create a systematic and scientific plan for revision.
Yeah.
And create a feedback loop through test series.
Test series, yeah.
This can be
yeah, that will be a good summary of what we have discussed.
For a strategy. Okay, sir, moving on, you mentioned that one should revise regularly. The syllabus of physics is also very vast and one has to practice extensively.
Yeah.
These are all very time intensive activities, and one has to balance them with GS preparation also.
Okay.
So could you suggest some time management tactics or some prioritization within the syllabus to make sure that one does not compromise on the overall preparation but prioritizes his or her time effectively?
Okay. I will start with divide and conquer. So you divide the syllabus in manageable sections. I keep saying that in my class, in previous sessions also I have mentioned this, that do not worry about what you are going to achieve in 6 months or 1 year. Worry about what you are going to do today and tomorrow, that's it. So make very short plans. So what I would suggest here is that the lengthiest part will be finishing the syllabus. That will take time, that should take time, because by giving a lot of time into that part, you become confident of a minimum marks, that there is a minimum marks you are going to get. By the way, this is not going to happen in any of the other humanities optional. In physics or in maths or in other science optionals, you can hope for that there is a minimum marks I am going to get, right? After that, you have to improve things. You have to further increase your marks. So for that, you revise things in a divide and conquer manner, that you have divided syllabus in a manageable section. You know your limitations, you know how much time there is available, limitation in the sense of time, how much time is available, and you also have to study GS. So you divide your day schedule. You do not divide your month schedule, don't do that. You divide your day schedule, that today what you are going to do, and you achieve that part. And you do that each and every day without a break. You are an UPSC aspirant, you cannot afford break. It should be very clear that you do not have the luxury of going on some vacation, maybe perhaps once in a while, once in 6 months or something like that. Otherwise, you cannot take break. I also do not think that you have to study 12 to 14 hours. Don't do that. I feel like that you are going to exhaust yourself very soon, and then you will take a very long gap after that. So study for 6, 7 hours, 8 hours perhaps. Out of those 8 hours, so for example, let's say 6 to 7 hours of study, 1 hour of newspaper reading, and perhaps some answer writing practice of 1 hour. That is what I highly recommend, right? So this is what you have to do almost on every day basis, okay? So manage syllabus, make your plan in a manageable section of the syllabus and stick to that part. Definitely do that. Take PYQs from a specific topic, whatever you have decided today, and solve those PYQs again, even if you have done that in the past. Always remember that in your mind, you know the concept versus when you are going to write the same thing on a piece of paper, right? So these two are connected but do two different things. So whatever you know in your mind, you write it down also, right? That is how most of the students improve their learning, improve their capacity, right? So whatever, make a very small concise plan of day and tomorrow, make a realistic goal. That realistic goal should include your optional, which is physics in this case, GS, some section of the GS, maybe paper 1 geography part, newspaper reading, and these 3 things only. And then you read those 3 things on that day, that's it. So that should be a manageable part, and you should achieve that. And you'll realize that in the course of time, in 4, 5, 6 months, things are already automatically falling into place, right? So this is how we improve, this is how we revise things, this is how we practice things.
Okay, so sir, what I've understood is that plan effectively, compartmentalize your day, create short goals, don't create very long goals, keep it sustainable, but you have to keep it consistent.
Consistent, yeah.
Okay, okay. Sir, this has been a very engaging discussion. Any final advice for our students?
I will simply suggest that if you feel, what I said earlier, if you feel that you have passion for this subject, if you think that you really enjoy reading physics, you are confident about your mathematical aptitude also, then do not hesitate in taking this optional, right? So, and you'll have to work hard, but that hard work will be very rewarding when you go and write men's examination. So I wish you all the best.
Thank you, sir. Thank you for sharing your expertise. Students, we hope that this session was useful and informative for you. Until next time, stay dedicated, keep learning. Thank you.